In this video, we're going to start with this brand new unopened laser engraver over here, and we're going to go through every step that you need in order to go from here all the way to burning your very first project. More specifically, we're going to cover these 9 steps. Number 1, we're going to actually assemble this laser. Number 2, we're going to set up the accessories we'll need. Number 3, we're going to go through some safety precautions. Number 4, we'll install Lightburn, which is a laser software. Number 5, we're going to configure some settings within Lightburn. And number 6, we're going to do our power and speed tests in order to understand what settings we'll need for our project. Number 7, we'll actually create our first design in Lightburn. Number 8, we'll do the align/framing that we need to do in order to position the laser module around our material that we're going to be using for the project. And number 9, we will actually burn our very first project. Personally, I've been laser engraving for almost a year now, and my laser business has actually almost hit $30,000 in revenue. But to get to this point, I have made a ton of mistakes, and I've had to go down a bunch of different research rabbit holes just to get things set up and working like they should. And I've still got a bunch to learn, but I thought I'd first come back and make this video, which is the laser engraving crash course that I'd wish I had when I first was getting started. All right, step number 1 is actually assembling the laser. Yes, these machines do come with some assembly required a lot of the times, and so the first thing we're going to do is just start putting this together. I should also mention that for this video I'm going to be using a diode laser. This is actually the type of laser that I use for my business, and it also is one of the most popular types of laser, especially for new people who are just getting into laser engraving. As you may have heard, there are other types of lasers as well, such as CO2 lasers and fiber lasers, but those are going to have different setup processes and some different safety considerations, etc. And so that's just important to keep in mind that some of these things are going to be different if you are using any type of laser that is not a diode-based laser. With that all said, this Xtool diode laser that I'm using today does come with a pretty nice instruction booklet to help you put things together, and they have a genuinely good video tutorial about how to put their lasers together online that you can find and use. And by the way, I want to say a quick thank you to Xtool for actually sending me this laser for free. I never would have guessed that I would be getting sent a free laser at just 3,000 subscribers here on YouTube, but here we are, and it's actually great timing because that will allow us to go through the complete end-to-end process of setting this laser up and using it, all the way from just completely unboxing it brand new like you would if you were actually buying your own laser. And once the laser itself is all set up, then it's time for us to add on some important accessories. And that brings us to part 2 of our video, which is setting up some accessories. Now there are 3 main different accessories that you're going to need with this style of diode laser, and so we'll walk through each one of those now. The first accessory is a honeycomb bed, and it usually comes with an included metal base sheet to go under the honeycomb bed, and I originally bought mine from Xtool directly. However, in hindsight, I probably would just buy one off of Amazon instead. There are several offered there, and most of them are a lot cheaper than the one that you can buy directly from Xtool. Next up is the air assist, and for that I would do one of 2 things. I would either buy this aquarium pump from Amazon that I've actually made a video testing it and comparing it to the Xtool air assist, and their performance is basically the same, despite the aquarium pump being dramatically cheaper than the Xtool version. And so if you want to use like sort of a standalone air pump like this, then you can go for the aquarium one on Amazon. I'll leave a link to that in the description below. Or you can use shop air, or you can use like a larger air compressor, especially if you have like a shop where you're using an air compressor already. You could use that for your air assist if you set it up correctly. Then you'll also need an enclosure. I'm going to be using one that I designed and built myself. I did originally use an Xtool enclosure because you can buy sort of off-the-shelf enclosures like this, but it really didn't work well for me, which is why I ended up building my own. And so this is something that you'll have to figure out a solution for, whether you decide to build one or buy one off the shelf. Once the machine and accessories are all set up, then it's time to look into some safety equipment. So this brings us to part 3 of our video, which is taking safety precautions. And there are a few main things that you're going to want to keep in mind and prepare before you actually plug your laser into an outlet. But before we go any farther into safety, let me just give a big disclaimer here. I am not a safety officer, nor do I have any formal laser training, and so be cognizant of the risks, make your own decisions, and be careful. With that said, I think there are 3 primary safety concerns that you need to address before actually turning your laser on for the first time. First, there's eye protection, and I personally do 3 main things to help protect my eyes from the laser. First, I leave the included shroud that's on the laser diode on. Some people like to remove this, but I have decided to keep keep mine on. Second is actually the laser enclosure that I built. The viewing panels on the front are actually laser safety viewing panels that I purchased from JTech Photonics. And so if you build your own laser enclosure, you could use some laser safety viewing panels like this, or if you buy one off the shelf, it may also come with some level of light filtering. And third, I always wear a pair of laser safety glasses like this when I'm working in my laser room with the laser on or running. But before we go any farther, let's talk about these laser safety glasses for a minute, because it's critical that you have ones that are appropriately rated for your laser. And the reason I bring this up is that a lot of times you'll get some safety glasses that look maybe something like this in the box with your laser when you buy them, but these ones that I got with my original Xtool D1 Pro just are not rated highly enough to make me feel safe when using my laser. So these laser safety glasses are a huge rabbit hole that we could go down, but it mainly boils down to two main considerations or ratings that they have on these glasses. The first is wavelength, and the second is OD or optical density. Of these two, I think that the wavelength is actually the simplest one to understand. And so if you have a diode laser like this Xtool D1 Pro 10 watt module over here, the wavelength of that laser is about 455 nanometers plus or minus 5. And as I understand it, that's pretty typical for diode lasers, but of course you'll want to check with the manufacturer on their website or just emailing their support directly to find out the exact wavelength of whatever laser that you're actually dealing with. So then when you go to buy safety glasses, all you have to really do for wavelength is make sure that the glasses that you're buying have a wavelength that includes the wavelength rating on your laser. So to just give you a specific example here, if we have our Xtool D1 Pro 10 watt over here that has a 455 wavelength, then I need to make sure that my glasses include that wavelength. And this pair that I use is a Free Mascot branded pair of glasses, and the rating for wavelength on them is 190 to 490 nanometers. And so that does include the wavelength of the D1 Pro, and so for this particular rating, we should be set. And if you want to check these out, I'll leave a link to them in the description if you're using the same laser, or if you just want to see an example of the types of safety glasses that I use, you can find that in the description. And next up, we have to understand optical density. So the OD rating, in the simplest terms possible, is basically just the amount of light that is filtered out through the lenses in the glasses. So the higher the OD number, the more light that it filters out and the safer the glasses are. Then the next logical question is, well, how much OD is enough? And it really depends on the specific laser that you're dealing with, and depending on who you ask, you might actually get different answers. One source that I personally like is this free OD calculator that's on the website for the Laser Institute of America. This calculator takes simple inputs of your wavelength and power rating of your laser, and then gives you an estimate for the minimum OD that you probably want to be using for that laser. You can see here that if we take the wavelength for our laser that we're using here in this video, and we also put in 10 watts, that it's going to give us an estimated minimum OD for that laser of 4. And I know because I asked Xtool support that the in-the-box glasses that come with this laser only have an OD rating of 2. So that's just not going to be enough to keep my eyes safe while using this laser. And if we take this example a little bit further, if we then go back to our calculator and we punch in 20 watts or 40 watts, which are also module sizes that you can get for a diode laser like this, you'll see that the minimum OD rating for these are actually a little bit above 4 OD. And so to be on the safe side, what I personally use is an OD6 plus rated pair of safety glasses, and that's these ones right here. Okay, that concludes our little safety glasses rabbit hole here. It took me a long time to figure some of this stuff out, and I'm sure there's stuff that I don't know, but hopefully you found that summary helpful. If you did, hit the like button for me. I'd appreciate it. All right, next safety thing. Let's talk about smoke. If you're using your laser indoor, you of course need to do something to exhaust that smoke and get it out of your house or out of your garage or wherever you're working, and so that's something that you really need to have a solution for. For this, I'll quickly tell you what I do. I have this laser enclosure over here that I built, and I also have an exhaust system. I have a duct that runs out a window over here and another one that brings air in over there, and I have 2 exhaust fans. A lot of people just use one, but I have one taking smoke out of the enclosure and another one bringing fresh air into the enclosure. So there's a lot of different ways to do this, but in some capacity you're going to need an enclosure to contain the smoke, and you're also going to need an exhaust fit system, probably with some inline fans, in order to push all of that smoke out of your area. Finally, since we're dealing with lasers, there is also a fire risk. And so I do a couple of things to help prepare for that and to mitigate that risk. Number one, I monitor the laser while it's running to make sure that if there is a flame up or something like that, I can catch it really quickly. And I also keep a fire extinguisher right next to the enclosure, just in case something would catch on fire, I can stop it right away with that fire extinguisher. Many of these diode lasers will also have a fire sensor that will stop the laser and sound an alarm if it senses some sort of flame up. And I actually do have that on this Xtool D1 Pro, or at least the one that I've been using up to this point, and it does seem to work pretty well actually in my experience. All right, now we're on to the process of installing Lightburn on your computer. And before you do this, you may actually need to install something called a CH340 driver as well. And don't worry, it's not as complicated as the name makes it sound. All you have to do is go to this link, which I'll put in the description of this video, and then you get to this page and you can choose the driver download for the given system you have. So if you have Windows, Mac, etc., then you can go and find the appropriate driver. So for me, I'm using a Mac, and so I'm going to scroll down here and I'm going to look, and I'm going to find the most up-to-date package, which is this 1.5, and that's going to be the one that I then download. And that brings us on to the next step. All right, now that I have the driver downloaded, I can just open this package and install it just like I would for any other installation package on my computer. And so if you're on a PC, obviously this might be a little bit different, but this is the flow. And I don't need to show you this because, you know, it might be different depending on how you watch it. But what I do want to tell you is if you're not sure whether or not you're going to need this driver, because not everyone will, I encourage you to go to YouTube and search for Lightburn for, and then the specific model name of your laser. So for example, if you have an Ortur laser, you would say Lightburn for Ortur. And the company that makes Lightburn has actually done installation and setup guides on YouTube for a lot of the most popular lasers. So they have one for SculptFun, Ortur, Xtool. I know those three for sure, and probably some others as well. So go check that out if you're not sure. Otherwise, you'll need to do what I'm doing right here, which is installing this driver package. All right, the next thing we have to do, once we have the CH340 driver thing all sorted out, is just to go to Lightburn. And I have a link here that I'll again put in the description where you can go straight to the downloading of the free trial. So if you haven't used Lightburn before, you can get 30-day free trial of the software. And then after the free trial, you do have to pay for it. It's about 60 bucks. It's a one-time fee, and for what it can do, it is a bargain, in my opinion. You can do a ton with it, so it's well worth the price. And then you can download it for Mac, which is what I'm using, or of course Windows and Linux, whatever you have, you can download there. So I'm gonna go ahead and start my download. Then once you have it downloaded, all you have to do is the normal install process that you would do for any app or program on your computer. For Mac, it looks like this. For PC, it obviously looks a little bit different, but you just install the downloaded file on your computer, and then we're off to the races. And for most diode lasers, this will actually be the last step of the software install process. But if you're using an Xtool like I am, then you actually have one additional step, and that is to download the Xtool Creative Space software, because they have their own software, and you do have to configure some settings in their Xtool software in order to get everything to cross over to Lightburn. Kind of a long story, but even if you intend to use Lightburn and you're using an Xtool, you still do need to download and install the Xtool Creative Space software. So that looks like this. This is their software page. You just go to their website, click software, and then you can download it right there. So this is what you would do if you have an Xtool. But since the installation of this Creative Space software is only going to apply to people who are using Xtool diode lasers and not to other people who are using different branded diode lasers, I'm not going to cover the rest of this process. However, there is a really well done video by the channel Buster Beagle 3D that I'll link in the description that walks through all of like the configuration and settings that you can use inside of Xtool Creative Space when you first install it and set it up. And so I encourage you, it's like an hour-long video, but he covers all of that Xtool Creative Space setup stuff in like the first 5 or 6 minutes of the video. So definitely go watch that if you need help with this specific step. All right, and that brings us to the next step of our process, step 5, which is configuring some settings within Lightburn. So at this stage, we can go ahead and open up Lightburn. We see it is now installed and with the other apps on our computer. And the very first thing that it's going to do when the program opens is it's going to ask you to add a device. So we have this devices pane here. And before this is going to work, we first have to, of course, connect our laser to our computer. And so in order to do that, it's just 2 simple steps. You need to plug your laser into power if you haven't done that already. Turn on the power switch on the side of your laser, and then also plug the USB connection from your laser to your computer. I have USB-C ports only on my laptop, so I actually use this little dongle to get the USB to connect. And once you do those things, then we're ready to actually do this part in the software of adding. And so for most diode lasers, what I would use is this Find My Laser button. And what that's going to do is just search for any laser that's connected to your computer and to sort of import it that way. But for Xtool, which is what I'm using, they actually provide, the manufacturer provides what's called an LBDev file, which again sounds more complicated than it really is. And so in this video here, I'm just going to go grab that file real quick since I am using an Xtool. And I will leave, if you are also using an Xtool, I'll leave a link in the description to get this if you want to. And if you scroll down the page a little bit, you'll see that to configure your file, you can download this Xtool D1 Pro LBDev file. So I'm going to download that, and that will show up in your download folder if you're using a Mac. And then what this allows me to do is, rather than use Find My Laser, I can use Import. And so I'm just going to go to Import, and then I'm going to go to Downloads. And we have this Xtool D1 Pro file here that we just downloaded, the LBDev file. I'm going to open that, and there we have it. It's just going to add this laser for me right here, and it's going to basically set up the specific settings for Xtool so that it's all ready to go right here. And then I'm just going to select it and click OK. The very next thing I'm going to want to do is come up here to this little gear icon, and I'm going to configure a setting here in Lightburn's basic settings. And pay attention to this because this is one of the more common questions that I get, and that's how to change the units that you use within the work area of Lightburn. And so there's this little section here that says better for CO2, better for diode. This is where you change the units that you're going to use in the working area. Personally, I like to use this one, which is inches and millimeters per minute. But this is kind of a personal preference thing, so you could use something different if you wanted to. And for me, that's all that I'm going to change here for my Xtool diode laser. So I'm just going to press OK. Next, we have another batch of settings that we're going to configure here in Lightburn before doing any designs, and that is accessed from this little wrench icon here, and these are the device settings. So these now are the settings specific to the device that we're using, which in this case is my Xtool D1 Pro. And there's a lot here, so this can be a little bit overwhelming, but I'm going to give you two things that will hopefully reduce that overwhelm. The first thing I'm going to give you is a link in the description that goes to the official page from Lightburn that actually explains and defines what each of these settings are, so you can find that in the description if you want to learn more. And the second thing I'm going to give you is I'm just going to show you only the specific settings in here that I personally change. Now, depending on the device you're using and your specific situation, you might differ a little bit from what I do, but I'll show you the ones that I'm going to specifically change. Okay, so the first thing that I want to just draw your attention to is this working size. So what is here has already been added from the initial import. So this is correct for me for now. However, if you had the situation where you're adding some extension rails to make the working area of your laser larger, which I have done myself in the past, then this is where you could come to tell the software that you actually have extended the working area of your laser, and that correspondingly will change the size of the software like frame that it gives you in which to put designs and work, because it knows, okay, now your space is larger. And so you can change that here if you do add extension rails or something of that nature. And then also over here, I'm going to turn this off. If you want to read more about what this laser offset is, you can, of course, go to that link in the description I mentioned. And the next thing I'm going to do is I'm going to go to this other options section here, and I'm going to turn on this fast white space scan. And so long story short, if you're doing an engrave where there's lots of gaps between different like dots or lines that you're engraving, then this can save you a lot of time. And so for my purposes, I use 10,000 millimeters per minute. You might choose a different speed depending on your laser, but that's what I'm going to go with for now. And then there's one more thing that I'm going to change over here, and that is this laser on when framing. And so this, you'll see the help text coming up here, and it says this can be incredibly dangerous for CO2 lasers. So you have to be really careful with this. Make sure you know what you're doing if you're going to enable this. I've used this before. I'm using a diode laser like I mentioned, and so I'm going to turn this on in order to help me when I'm doing my framing, which is something we'll cover later on in the video. Okay, that's the last little setting I'm going to change here in device settings, but there's one more thing that we can do setting-wise that's in another location that actually makes this laser on when framing a little bit safer for my diode laser here, so I'll show you that next. So I'll press OK, and then I'm going to come over here onto the right pane, and I'm going to click Move. Okay, so I'm going to find this Move tab, and the next thing I'm going to do is come over here to Power. So this Power is the power setting for test firing and also for framing. And what I'm going to do here is I'm going to change this to a very low amount to make it as low as I can possibly make it while still making the laser dot visible. And so for this one, in the past, I've kind of tested it around and figured out that the lowest I can use for a 20-watt module is 0.3%. So I'm going to just guess that for a 10-watt module, I'm going to need 0.6%. So let's just put that in for now as a placeholder. So I'm going to change that there. And then the next thing I'm going to do is I'm just going to check my distance and speed settings. If you are using these little dials to move the laser around in your working area, or if you use this feature here, which kind of moves the laser head to a specific location, then you're going to want to make sure that these are at a reasonable setting. Otherwise, it's going to be like incredibly slow. So this is okay, actually. A distance of 1 inch and speed of 4,000 millimeters per minute. That's about what I set it to, even if I was setting this up and it was zeros or something like that. So that looks pretty good to me. All right, now that we've gotten some of those boring settings things out of the way, it's time to do something a little bit more fun, which is to do our power and speed tests. And so for any type of project that you're doing, if you're working with a material that you haven't done before, which of course is the case when you're just first starting, then you need to run some power and speed tests to determine that for your laser and for this particular material, what settings you need to do when you're setting up the project. And so today we're going to be working with this. This is 1/4 inch white oak plywood, just because I happen to have a bunch of scrap pieces of this lying around the shop. And there's a bunch of different ways you can do this sort of power and speed test. But one of the easiest ways is just to copy the one that we created. So we have this file, and if you go to my website, I'll put a link to this in the description. You can go and just sign up for my email list, and then from that email list, you'll get emailed straight away a link where you can get this file. And so once you do get that, if you decide to go about it that way, what you do is you just go over here to Lightburn, and you go File, Open, and then this is the exact file that you would get from my website. And so I'm just going to open that, and then it'll come in looking like this. And so there's a lot of different things here, but basically what I'm going to do is I'm going to show you how we can get this ready for running. And so I'm just going to do a couple quick changes. So because my piece is sort of like vertical like this, that's why I'm putting these two grids side by side. And you can see that on the left I have my engrave test. So if you're just doing an engraving, you only need to run this box. There's also a text test. If you're not doing any text, you don't need to run that. And then this one is a cut test. And so if you're just doing a cut, you would just do that. Or if you're doing cut and engrave, then you want to do both. The project I have in mind for this video today is both a cut and an engrave. So we're just going to go ahead and run all of this. You'll see that by default, there's a little label here that says 3mm birch. Well, I'm actually using a 1/4 inch white oak, as I mentioned. So I'm just going to change this to 1/4 inch white oak. And then do the same thing over here. So we're just kind of changing the labels. And then one other thing that I should mention is that if you are using a laser, this particular file is originally designed on a 20-watt Xtool D1 Pro. And so if you're using a much more powerful or much less powerful laser, then you're probably going to need to make some tweaks to the speed and power settings. I haven't tried this on the 10-watt that I'm using today, so I'm going to go ahead and just give it a shot and we'll see how it turns out. It is a less powerful laser, so because of that, it's probably a little bit less dangerous than if you were jumping up to a much higher power without changing anything. I think you get the idea there. So that's the first thing I've done, is just change those labels. And then the next thing I'm going to do is I'm going to create a little framing box around this. But we're going to be talking a lot more about framing alignment and running a project in Lightburn more later. And so for now, we're just going to fast forward ahead. I already actually ran this test file. So here it is. This is the finished test file that I ran on that scrap material. And now let me just briefly explain how you actually interpret one of these test grids. All right, let's start with the cut test over here on this side. So basically what you want to do is look at the cutouts here, and I use stars for this because when you do the corners, like little tiny detail corners like this, sometimes you get the worst scorching in those areas. So we're just going to look at the ones that actually cut out. So these obviously up here don't work. And so we're just gonna ignore those. But everything that cut out is a potential option. And what you'll see is that this is basically a grid. On the right-hand side, we have the speed in millimeters per minute. And on the bottom, we have the power setting. And we also have this line in the middle, and that separates on the left side. This is one pass at that power and speed intersection. And on the other side of the line, we have two passes at this intersection of power and speed. And so then I'm just gonna look at all of these cutouts and decide, okay, which one looks like it's the cleanest cut, the least amount of scorching, etc. And to me, some of the best ones look like the ones that are at the 200 speed, 200 millimeters per minute, and the 90 power intersection. So this one here looks good to me, but also the one pass version looks good to me. So if they look, about the same, then in that case, it's gonna be better probably for me to do just one pass because that of course will take less time. Another thing that you can do that I don't think I've really seen anybody talking about online with these test cards is you can also look at the back for a cut test like this. And for our example here, if say you're trying to decide between the two pass of the 90 and then the one pass, so these two stars here, well, you can see that the one that has one pass, which is this one here, it actually has a bit less scorching than this one over here that has a little bit on the side. So with two passes, it's actually getting a little bit more scorching, which makes sense. And if you're doing something like a Christmas ornament or something like a display piece, for example, and you're gonna have like both sides visible, then seeing how much scorching is on the back actually does matter because then you have to do less sanding or touch-ups on the back of the piece. So that's something just to keep in mind if you're trying to analyze this really closely. So that's the basics of the cut test. So because I like this 90-200 intersection with one pass, those are the settings that I'm going to use later when we come back and design our project. I'm going to use a power of 90, a speed setting of 200 millimeters per minute, and one pass on the laser. Okay, let's move on. So over here we have text. And the reason for this test is really just to show you how large the different text sizes are. So that kind of just gives you an idea of how big it's going to be depending on the size that you use. So that's what that is. And then over here for the engrave test, it's basically the same sort of process as the cut test, but it is a little bit more subjective. So for the engrave, you're just gonna kind of basically look and think, okay, how do I want this to come out? Do I want something that's on the lighter side, or do I want something that's like a darker and deeper engrave? For our project that we're gonna do here, I'm gonna say, I want something that's a little bit more subtle. So we're gonna go up here and look at these options, and I think the one that I like for what I'm gonna do is probably this intersection of 40% power and 10K. So it's kind of dark, but still a little bit subtle. So we're gonna go with that one for our upcoming project. All right, now that we have our power and speed set out for our white oak material, we're gonna go ahead and just create our first design here in Lightburn. So I'm gonna go up and just open a new project. And I don't wanna save this, so we're gonna go, and now we have a nice blank workspace. And because it's coming up on the holidays now, I think we should just go ahead and make a fun little Christmas ornament. And my brother has a dog named Charlie, so I thought I'd try to make a little bone-shaped ornament with Charlie's name engraved on the top. So let's see if we can do that here. So on the left-hand side, you'll see all of the tools that you have here in Lightburn. I'm not going to explain every one of these because I actually did a full crash course on Lightburn. And so if you want to learn about a lot more detail about all of these navigation tools and what you have available here, then definitely go check that out on my channel. But for now, I'm just going to basically show you what I'm going to be using here. So I'll use this rectangle tool. And I'm going to set it to basically the size that I want this to be. So I'm thinking a decent size will be about 4.5 inches, and that will also fit pretty well on the scrap material I have. So I'm just going to put that in, and then let's see, do we want to be that to be a little bit taller? No, that might be all right. So let's start with that and see how it looks. And so now I'm going to get a circle, and I want to make a perfect circle here. So for that, I'll hold the Shift key, and I'll get my perfect circle. That looks to be pretty close to the right size there. And then I'm going to move this down. Let's zoom in so we can see a little closer. All right, and then I'm going to just copy this shape to make another one. And then I'm going to select both of them. And we're just going to use these handy dandy alignment tools up here. These are things I use all the time. So let's just do an H, whoops, wrong one. Actually, I want V center. And so those will center the two shapes there. And then I'm going to group them, and I'm going to do a centering action here with this. So I'll do this and this, and I'll do the other alignment now. So, okay, so now you can see those are aligned. So these alignment tools are super handy, which is why I'm using them so much here. And so then I'm just going to take this group shape that I did, and I'm going to make a copy, and I'm going to put this on the other side, and we're going to again do that same alignment we just did a minute ago. So now everything should be sort of aligned here, and what I'm going to use now is this little merge tool. All right, and we got some cleanup to do here, so we'll figure that out in a second. But now I'm just going to do this and get that one. So we've got that combined now, and so now we've got pretty much everything except for we have this this weird little opening space here. So let's see if we can get rid of that. So what I'm going to do next is I'm going to just get a little circle, and there's a bunch of ways that you can do this, by the way. So I'm just going to kind of do a quick and dirty situation, and then I'm going to select that and our overall bone shape. Let me zoom in so I can get it. There we go. I got it. If you're not able to select something right away, usually the problem is you just need to hit the escape key. That's what I was just running into. So you see, I just kind of cut that off there. There's a little bit more, so let me clean that up too. I could have gotten that a little bit closer there. So let's just do that. All right, that ought to do it. So I'll select this and this. Do the merge. All right, so now I have a pretty clean in there, and then I'm just going to do the same thing on the other side. All right. So this won't be 100% perfect because I'm trying to be quick. So there we go. So that looks pretty good. So that kind of looks like a bone, right? That's not bad. So that's going to be our main shape outline. And what we're also going to need is we're going to need a spot to run some string through, like some threads, so that we can hang this on something. So I'm going to just get another circle here. And I'm going to hold the shift key so it's a perfect circle. But I already know, because I've done stuff like this before, that the size of the string that I use is pretty much always going to be under 0.2. And so I'm just going to change the dimensions here to 0.2 inch, and that will just go ahead and change my circle. And then I'm going to, whoops, got to do that escape key thing again. And then I'm going to move this circle down here. And then to make things easy for ourselves, we want this probably just to be dead center in the middle of this. So I'm going to zoom in, move it down a little bit, and then we're just going to select these two shapes, and then we're going to put it right in the middle. Whoops. I keep doing the wrong one there, don't I? There we go. So that's nice and centered in the middle of that then. Now all we have to do is put our text right here in the middle of this. And so I'm just going to use the text tool, and we're of course going to want this to be a bit bigger. And so let me just increase the size to something that looks appropriate. All right, let's start with that. And I'm going to use one that I think is kind of fun looking. It's like a Baloo, starts with Baloo. And I'm going to write in my text box, I'm going to write Charlie. All right. And then I'm going to just go ahead and take this. We might even need to make this a little bit bigger. Let's make it bigger. All right. That's looking better. All right. So now we can do our centering again. And look at that. I used the right one this time, but we're actually going to use both. Okay, so here we go. So now we have all of the main components of our design here. And so obviously some of this is going to be a cutout and some of it's going to be an engrave. And those are going to need to be on different layers. So let me show you how to do that now. So we need this little circle to cut out, and we need this overall shape to cut out. And so what we're going to do here is we're going to put this all on a layer. And so you'll see these shapes down here at the bottom. And I'm just going to make it red since it's a cut. And so now this is going to be where we enter our settings that we got from our cut test. And so if you'll remember, we did 90% power. And so that's just this power percentage here. So we'll just enter 90% power there. And then the speed that we had, it was just 200 millimeters per minute. And so that's that. And we were doing just one pass. And then the only other thing you got to change here is this came in as a fill mode. For a cut, it's always going to be a line mode. And there's more stuff you can actually change on this if you want, so you can open this up. But I'm just going to change the name here. And since we're using it for cutting, I'm just going to do cut. All right, so that's going to be our cut layer. And then we just have to set our engrave layer. So that's going to be the Charlie text here. And so now this very logically is going to be the settings that we got from our engrave test earlier. And so that's going to be 40% power. So let's punch that in. And actually, let me move this. We're going to do layer 1 here. So 40% power and 10,000 millimeters per minute. So that's 1,000, 10,000. And then I'm going to change this to 40% power. And this is one pass. And then it's fill, which is correct for an engraving. And then I'm going to just change this to engrave. And that's going to be everything that I change for this for now. Interval is another thing that you can sort of hone to tweak to make it more precise and line it up with your laser. But since we're kind of just doing a quick design, I'm not going to get into the detail of that. So we're just going to ignore it for now. And I've just noticed that this is a little bit too big for my scrap piece of wood that I'm planning to use. And so I'm going to show you actually a little trick that we're going to use to solve this problem. I'm going to just group everything so that I can resize it more easily. So group, and then I'm just going to resize it to something that is going to fit on my material. So I think the maximum is about 5 inches. And so let's just go somewhere around there. That ought to do it. This is going to be a little bit small, but I think it'll still be a good example, and it fits on my scrap material, so I won't have to get a new piece of wood out. All right, so let's move on to the next step. And now we're on to step number 8 of the process, which is framing and aligning our project onto our actual piece of material under the laser. And there's several different ways that you can do this, and I actually covered, I think, 3 different methods for doing framing and alignment in my Lightburn crash course video, if you want to watch that on the channel. But today, I'm just going to kind of give you a condensed version, and I'm going to show you only the framing method that I think I personally use the most often. And so in order to do that, basically what we're going to need is we're just going to need to box in our design with a rectangle, basically. So we're just going to create a shape right around our design here and make sure everything fits, but we basically want to get as close as we can to our design without actually touching it or passing the edges. And so that is looking just about right. Let me get this one a little bit closer. And then I'm going to take this and I'm going to have it on its own layer. So I'm just going to say, okay, it's layer 3. And I'm going to just call this my frame. This is my frame layer, just for this example. Okay, and I'm going to change these power and speed settings to be something that is not going to cut or engrave anything. It's going to just barely show the laser dot enough that we can actually see where it's going to frame in the project. And so I'm actually going to use the exact same settings for this that you might remember that we entered for our power in the move tab earlier. So I'm going to use 0.6% power for this. All right, here we go, 0.6. And I'm going to do the speed, 4,000 or 5,000 millimeters per minute usually works pretty good for me. So I'm just going to go with 4,000. And then we just need a few passes for this because it might take me a minute to make little small adjustments. So I'm just going to give myself 3 passes for this. And this is always going to be a line. for the mode. So that'll be the settings for our frame layer. And so now to actually do the framing and the alignment, I need to turn everything off except for that frame layer. And then I'm going to go over to the laser and I'm going to first focus the laser module above my material so that it's the correct height. And then I'm going to frame it in using this here. All right, here we are at the laser, and I should mention that I have my laser safety glasses on before I even turn the laser on. But now that we've got the laser on, I've got my material in here already, and the next thing I'm gonna do is just go ahead and focus the laser. Now the Xtool has a little kickstand for this purpose, some lasers use like a little bit of a spacer, but for Xtool it has the kickstand, which seems to work pretty well. So I'm just going to do that, and now that I have that done, what I'm doing is I'm basically going to try to manually put into position the laser module roughly to correspond with the position of the little green dot from Lightburn. So if we look at Lightburn here, you see this little green dot. With relation to the actual body of the laser, I'm going to try to position my laser to where that green dot is. So I'm going to bring this in just a little bit closer, and I think that this looks pretty close to where that green dot would be. So now I'm going to go ahead and go back to Lightburn, and I will activate the run job for the frame layer. So I'll turn the output off for all other layers, and I'll just turn it on only for the frame, and then I'll click start. When you do this, it might come up and have a little pop-up that says cut might be out of bounds. And the reason it does that is because we've basically manually positioned the laser head module and we haven't used the home position. That's a topic for another video, but for now, I'm just going to click OK. So now we can see that the laser dot is moving and it's a little bit off of the wood. So I'm just going to move that wood back a little bit to make sure that my laser is going to be positioned entirely on top of the wood. And that now is looking pretty good. And then I just needed to go ahead and close the enclosure and then turn on my exhaust fan and my air assist, and I was ready to run the project. All we have to do is come back to our cuts and layers over here and just turn off that frame layer that we just did and turn on, of course, our cut and engrave layers. And a best practice I'll throw in here is a lot of people like to do the engrave before the cut, so you can just put that at the top in order. So engrave, cut, and then once you have your output for those on and the frame layer off, you can just go ahead and click start to run your laser. So now we've already basically started part 9 and the final section of this whole tutorial process, and that is running the laser job. So you can see the laser running there. And when it's all done, then I'm just going to come back over, open up the enclosure, turn everything off, obviously, and open the enclosure and see what we've got here. Now you can see that the project is done, but it does have a couple little strings holding on. Sometimes this happens, and if you want to get rid of that, sometimes you can just up the power or play with the settings, but I'm just going to knock them off here with an X-Acto knife, and there we have it. All right, here it is. This is our project, and I honestly think it turned out really nice, especially for a first project on this laser. A fresh install of Lightburn and getting everything set up for it to come out this nice is pretty great. So I'm excited about this. And 3 quick things before we close out here. First of all, if you've made it all the way to the end of this really long video, just want to say thank you for watching. I hope that you have found it helpful. Number 2, if just a reminder that if you want that test grid file, you can get it for free by signing up to my email list. And I actually have a couple more free files in mind that I want to make for you guys. And so the email list is the place to get those if you're interested in that sort of a thing. And then the third and final thing is, if you have found this video helpful, a like to the video and also a subscription to the channel would be great. So thanks again for watching, and I'll see you guys in the next one. Bye.